So to solve this one, we need to isolate that square root. Square root of 7x minus 3. Notice it's not like we would with regular equations where we're isolating the variable. We're isolating the square root so that we can square both sides. In fact, I guess you could square both sides right now, but it's going to be better to get rid of that minus 1. So let's do that first. So I'm going to have to add 1 to both sides. Now I can't take x and add 1 and make it 2 x's because they're not like terms. I have to keep them separated, right? So that's going to zero that out. I'm going to drop then my square root of 7x minus 3, which now equals x plus 1. So now that I've got it this far, let's take both sides. Since I've got a square root, I'm going to square both sides. But yeah, now we got a binomial that's being squared. The good news is that the exponent 2 and the square root get rid of each other. So I at least have the 7x minus 3 there on the left. And it's going to equal, but I got to take this x plus 1 and square it, right? So I got to multiply it by itself. Now we do have algorithms to just kind of get this x squared plus 2x plus 1. But just as a quick reminder, let's go through the process there. So you got x squared, x times x, and then x times 1, which would be positive 1x. Then 1 times x, which would be another positive 1x. And then 1 times 1, which is 1. So simplifying this, I got x squared, 1x plus 1x would be positive 2x's, and then the positive 1. So we end up with a trinomial right there, and now we're essentially solving for the trinomial, right? Which means that the 7x and the minus 3, I got to get rid of those. I want this to equal 0, right? So I can just take the roots. So I'm going to subtract 7x from both sides. So 2x's minus 7x's would be negative 5x's. But also, I'm going to add 3 to both sides. Okay, and again, that's to zero out both of these, so I end up with just 0 equals. But 1 plus 3 there would be positive 4. And the x squared, nothing to do with it, it just drops x squared. So now I'm just factoring this trinomial. And if you wanted to, you're welcome to factor by grouping. But I'm going to use the rule, the two factors of 4 that add up to negative 5 would be negative 4 and negative 1. So that would then give me 2 new binomials with x's. And I got negative 4 and negative 1. Now this still equals zeros, right? If I can get both of those factors, x minus 4 and x minus 1, respectively, to equal 0, then I have my two solutions. So x minus 4, if I could get it to equal 0, then it would be true. But also if I get x minus 1 to equal 0, that also would be true. It will make the equation true. So yeah, just solving these equations like you usually would. So we'd have to add 4 to both sides for this first one, zeroing that out. So x then equals 4. And then same thing with this other one, just add 1 to both sides to zero that out. Now x equals 1. 0 plus 1 is 1. Now these should be our two solutions, right? But I do need to check both. So I'm going to go back to the original equation twice. Now let's just start with x equals 4. So I'm going to take the x's. I'll fix it. And let's replace those with 4s. See what we get.
Yeah, 4 does it.
Yeah, right? Because that'd be 28 minus 3, which is 25. Square root of 25 is 5, minus 1 is 4. And so, yeah, you do end up with 4 equals 4 on this one. That's true. So that clarifies that first part for us. But, yeah, let's check. Let's check. So x, now we're going to say is 1. And let's check for truthfulness here. So 7 times 1 is 7, minus 3 is 4. Square root of 4 is 2. 2 minus 1 is 1, yeah. That does check off. 1 does equal 1, which is true. So now we know that both of these are correct. Now in the assignment, you just usually type in 1. Doesn't matter which order, but then you just separate them with a comma. And either way, I mean, it's the same thing. Now let's say that something came out false, like one of them was true, one of them was false. Okay, if it's false, you just may want to go back and check your work on that, but it may also just mean that answer just is outside of the domain as well.